Hello, all together. We are very happy that you joined our talk today. And we're going to talk about the promises and perils of using artificial intelligence in software development. Just to say it before, and we don't forget it, this title is generated by ChatGPT, so it's not our original title. Also for this reason, we lawyered up this year, so we took a lawyer with us so we can explain you some other stuff we don't know at Ubique. I hope you find it interesting, but first we're going to introduce ourselves a bit. I'm Cléa, I'm an Android developer at Ubique since 2017. I also graduated at ETA with computer science, and now I'm not just working only as an Android developer, I also do a lot of project management, and I'm looking forward to tell you a lot of things.
Yeah, so I'm Patrick. I have a master's in physics. I'm one of the few at Ubique. And I joined Ubique 2014 and was working there as a student. And currently I'm overviewing security engineering and stuff like that.
Hi, my name is Marius. I'm a long-term friend of Patrick. I studied law and just passed the bar exam this summer. And since I was always interested in computer science and that kind of stuff as well, he asked me to join up, and I'm very glad to be here today.
But first, before we start, just a couple of words to Ubique so that you know from where are we coming. We have our offices close to ETH. Exactly when you look here, it's in the blue circle, so it's basically walking distance up to the ETH. What are we doing actually besides of thinking about artificial intelligence? We are doing mainly apps. I think probably at least one or two you have installed on your mobile device. Otherwise, I would be worried for you how you ride your train. We are a team about 50 people, 54 people, and we develop everything here in Switzerland. And if you have further questions to this, you can also ask us after the talk to it. But now let's start with the talk. First, we're going to talk about large language models in a short introduction, but you maybe ask, why do they even need this? They're just doing mobile apps. Yeah, last quarter we had a small problem. We developed a Simply app, we call it. It's an SSI app where we can enable EID and the possibility of getting a ticket for going into a climbing hall. And all the text we generated in German, because we're all basically native German speaking. So this is our tool to store data regarding to strings and everything in an app. So we had all the strings in German, and now we also wanted the strings in English and in French, and due to the fact that this is a POC, so we don't want to spend a lot of time on translating strings or hiring someone to translate it for us. We searched for a solution to get good translations. So first question is, why not Google Translate? It's easy. Probably also has an API. I don't know if you ever had to read a paper translated by Google Translate. I think the paper, you will not understand a lot of things in it. So we thought, let's try ChatGPT. And before we tell him which strings he has to translate, we gave him the context, so what's the app about and what's the surroundings. And also in our tool, we are able, for each string we have in our app, we can add a context and have more information about what this button should do. And in addition, we also added some more difficult words. For example, the word credential, we had to translate to French, and sorry for my French, it's justifications. No, I went wrong. It's terrible to go from English to French. But the goal was basically to tell ChatGPT some words which we knew he probably gonna do wrong, and tell him already this is the correct translation because it's a technical translation. Input then after it all our strings from our app, and voila, at the end we had all our content translated, which was really fast and easy, and we also checked it with several persons which are native French or English speaking, and it kind of looks good with not a lot of effort. So why does it work? And why does Google maybe not work in this case, or other language tools? It's because of the embeddings. It enables us to give kind of a semantic to a translation. So we can add content and tell the machine basically what is the topic about he has to translate. What does it mean? We have like these examples which can fail in translation. For example, that I'm afraid of bats, or that's the bat I beat you with. It's when you literally just translate one word, which we have quite often in our apps. When you have just a button with one word on it, it needs the surrounding context, otherwise it doesn't work. And that's why with ChatGPT, with the embeddings, it worked quite nicely. And Patrick tells you now a bit more about the embeddings.
Yeah, so the basic problem we have when we want to translate sentences or like give context to something, we need to translate words which humans are kind of good with working with to numbers or vectors where the computer performs best. So basically an embedding is a translation of a word into this high-dimensional vector space, encoding all the different parts of how this word could be used. For example, when we go back to like example sentences, we have this: he is taking a class to train for a new job. ChatGPT or like an embedding algorithm would probably or would maybe embed this word as this vector, or encode this word as this vector, which has many, many, many dimensions. And if we compare it to she took a cross-country trip on a train, this would be represented differently. Exactly. And in the end, what we basically want to do, we want to measure the distance somehow, or the similarity, by looking at the two vectors or the multiple vectors and compare there with any metric, distance, or other algorithms you might think of. But the question arises, how do we translate actually words to vectors? And I just shortly show you the concept from one of the most famous examples. It's Word2Vec. It's an algorithm patented by Google researchers in 2013. And basically, it's just a small two-layer shallow neural network where we input like all the words or the words, and it gives us some kind of representation in some, we call it vector space. Basically, there are two different ways Google proposed the algorithm to work. One is the continuous back of words, where basically you feed the neural network a sentence and you black out one word. And then you slide this blackout word like across the whole sentence, and you try to train your network to reproduce the one word you were like blacking out. The other way of working is the skipgram, where you input one word and you try to reproduce the whole like words next to this word. And both of them basically learn on the input sentences and what best fits with your word. And in the end, you get a probability distribution of which word fits best in this context. Exactly. Usually what Word2Vec produces is something where words with similar context are close together, or where the relationship between two vectors are somewhat defined. The most famous results, where you can actually read everywhere if you Google Word2Vec, is king minus man plus women equals queen. It somehow works. It's not 100% correct, but it's one of the most famous results. Or where it actually performs very, very good is at capitals, where you can subtract Greece from Athens and add France, and you get Paris, obviously. So this was really interesting, and I think it's also ongoing research and really cool to see that these embeddings kind of give us also new tools to do like linguistics, because like the relationship between words seems to be inherent in the sentences.
And that was my cue, apparently. Thanks for that. So I will give you a brief overview over copyright law today. Just keep in mind, everything I say is not legal advice, and it's much more complicated, but I try to give you something that you can take home with. So the first question is, we have two, what's the difference between copyright and patents? Patrick mentioned patents before. Copyright aims to establish protection for an original artwork, and patents are generally there to protect scientific inventions. Now, I need to stand a bit closer to the screen, sorry. So, as I said, copyrights, they protect original works. Now the question is, what does the term work mean? This is the legal definition. For our purposes, it's anything where you can be creative, essentially. However, there will be a small caveat later. Just quickly, historically, that's also why it's called copyright. Societies needed rules who could copy, who had the right to copy an artwork. With the invention of the printing press, that became a big question, because people could very easily multiply a body of art, which took the artist a long time to create, but made it easy for the copier with very little effort. So, how does this all relate to software? Well, the first question is software protected by patent or by copyright? It is generally protected by copyright and not patent law. Why, you might ask? Well, because I tell you to, because I tell you so. Actually, because the government says so. You can see here, at the very bottom, where we defined what a work is, the lawmakers weren't really sure if it took creativity to code. You might disagree. Lawyers think you don't really have to be creative, it's all math anyways, right? So just to make sure that it's still protected, we just write it into law, and that works good enough so far. This is also the explanation. Math is the one universal truth, or so I've been told. And that's also why you can't patent, at least in Switzerland, a software or an algorithm, because the mathematical principle of the algorithm has always been there, right? So you couldn't, you can not really invent it, you can only discover it. Same with, back in the day, you couldn't patent an atom or like a different element from the periodic table. It's always been there. You might have been the first person to synthesize such an element. You can patent the process to synthesize the pure form of an element, but you can't patent the element itself. Now, there are software patents around the world. Patrick mentioned Google could patent their algorithm. In Switzerland, this is usually not possible to patent your software, your algorithm, as an abstract concept. However, if you tie it to an electronic device to achieve a certain purpose, you can also patent it in Switzerland. Now, what good does this all do for us if we get a copyright on our software? First and foremost, I and only I, as the creator of the software, can decide who can do what with it. And if you want to use it, you need my permission to copy my homework. Now, how does this all tie into artificial intelligence? We could ask ourselves, what do we need to feed our hungry AI? Lots of data. How do we get the data? Well, we scrape it off the internet. Did we ask the owners of the works that we scraped for their permission? Usually not, right? So maybe you've encountered Getty Images. It's a platform where you can get lots of images. Those images weren't taken by Getty Images, right? So how did they do it? They license it from their owners. What is a license? We will get back to this, so remember the term. It's permission to copy somebody else's homework.
When we talk about scraping the internet for code or information, how many of you know what is GitHub Copilot? Okay, quite a bunch. And who used it? Okay, I used it as well, and I know it as well. Hopefully, as I stand in front of you. Otherwise, I should not ask this question. But for all of you which doesn't know it, I use it mainly for my Android studio. It helps me to code. It suggests during I code to code, basically. I can also make comments, and the suggestion of Copilot is even better, and it shows me snippets, basically, for my problem to solve. It's quite convenient, and it makes you much faster when you code, basically. So how does it work? It scrapes, as Marius already told us, it scrapes all the code snippets from GitHub, from all the open source projects, basically, and makes you out of those code snippets reasonable suggestions so we can learn. It also takes your project into consideration, what you already wrote on it. And as you know, the number of snippets online is really large, and it provides you quite decent and fast suggestion as it uses a vector database behind. Patrick will later tell you a bit more about those vector databases. So where it maybe fails, it can have dangerous content or malicious, where you can have backdoors in your code and you're basically not aware that you just make a backdoor in your code because you didn't carefully read the code which was designed. So this can hurt our users, what we don't want, obviously, at Ubique. The code snippets are maybe not in the way we code at Ubique. I don't know how many of you work at a company already, but most of the time you have like some patterns which establish over time, and we like them and we want to use them, and maybe they're not used by all the people outside of Ubique. And yeah, it's not so convenient then for us. So for us it would be better if we have can plug in just our own code base, and as our own code base is not open source, we kind of need another solution, and we're already thinking about it. The GPU is already lying around, Patrick told me so that we can train with our private repository and maybe make it even faster for us to code. But all of this is just possible with the vector databases because it's fast.
Yes, so basically what we now saw, like how we came from words to numbers, but now we have to store those numbers, and obviously we store it in a database. And the embeddings we found, or the neural network found, are usually stored in their vector form in the database. And as some of you might know, if you have performance issues with your database, you put indices on it. But how would you do indices on vectors? I mean, it's like, sure, you can put indices on certain columns, but they are like they don't represent the whole vector thingy. So to allow for fast similarity searches, we actually choose some metric I told you before to measure actually the distance between two different vectors, and choosing this indexing method or this metric gives us different kind of ways how we can express similarities. For example, the most important similarity measures are the cosine similarity, where you basically just measure the angle between vectors, or the same one with the dot product, where you normalize, where you also take into account the length of the vectors, and of course just the usual metric, like a metropolis. Just any metric you can define in a vector space, basically. But how do we actually do the indices? How do we know if someone is close to me? There are multiple methods, of course, but I will shortly mention three things, namely the random projection method, where the idea basically is we take a matrix which projects our huge dimensional space into smaller subspaces. And according to some mathematician, this preserves the metrics and the distances and the similarity between vectors, as long as the projection matrix is truly random. So after that, we can apply well-known algorithms for nearest neighbor search, for example, k nearest neighbors on the reduced dimensionality, which increases the lookup speed, of course. We can also do something which is called product quantization, which means we subdivide our input vector into smaller chunks and assign to each chunk something which is called a code, which basically just describes this chunk. And to find those centers or these codes, we can apply another unsupervised learning method, for example, k-means, where we just try to cluster all the vector parts and assign the k-mean as the code, and then we can input a query, do the same algorithm, and find how many of those clusters actually match with our query, and the more that match, the closer we are. And the third method is so-called locality-sensitive hashing, where we try to find some hashing method to hash the vectors, and we use a hashing method which produces hashes which are close if the vectors are close, or that's at least what we want. And then we can put those vector hashes into buckets, and the better if you fall in the same bucket, you're similar to this group of vectors, and then you can apply a nearest neighbor search on this reduced set of vectors. And Marius is now going to tell you whose homework GitHub stole.
Exactly. So, whose homework did GitHub or Copilot copy? It's based on OpenAI's codex, and as previously told, it's all publicly available homework, so all open source code, essentially. Now, GitHub actually did their own research. It's possible, coming back to how creative do you have to be, a certain code snippet, even though it went through the whole neural net, the whole vector embedding and everything, it can still be that the output, the suggested code snippet, matches one-to-one with the snippet from the database. So legally, this means you used this prior work, because by definition, all software is a work, therefore protected by copyright. If Copilot gives out the same code snippet, it's under copyright. We need, therefore, the permission to copy the homework. This leads us to the question, who is responsible? Is it the person using Copilot? Is it GitHub for training Copilot? It's still kind of an unsettled question. What it means as well, as I mentioned before, licenses are the legal permission to copy your homework. There's two important categories here. One are the so-called copyleft licenses. Maybe you've heard of them. It essentially means if everybody can use this license, it's open source code, but if you use it, you have to open source your code as well. Now, how could that be of issue? Well, if Copilot suggests you a code snippet under copyleft license, you get your code contaminated. And you need to open source your code now as well. On top of that, you might not even know that the code snippet Copilot suggested is under such a copyleft license, therefore you won't even know that you should open source, and that can be quite a quagmire. Another one is some licenses, you can use it proprietary, you can have closed source code afterwards, you just need to attribute which snippets of code you took from somebody else, you need to mention the author. One might think, well, that's easy enough, but I already told you the issue before, Copilot doesn't tell you. So you're essentially in the same situation. And as a side note, every downstream user, so let's say those guys use Copilot at Ubique, if then you download their app, technically you're also running the code which violates copyright, so this might also mean that you guys violate copyright just because you use the SBB app. Now, we get to the next part.
So what's the solution there? I really want to use it.
Well, it's very easy. Just don't use it.
Yeah, but they really, really want to use it. It's such a good tool.
Well, just don't tell anybody. How would they ever know? I mean, you don't open source it, right?
Yeah, but we are honest people at Ubique, obviously.
All right, I guess you could manually look up all open source code on GitHub and see if Copilot suggested anything of that. Or you can wait until they release their tool, which actually allows you to filter back through and see if any code snippets that you used were under a license. Or you could try to lobby lawmakers into loosening copyright law. Have fun with that one. Or, and that's the next thing, there are some legal concepts proposed that it could be fair use, etc., but there you need to wait for the courts until they establish a clearer precedent.
Yeah, but we already used it though. We tried something, I'm sorry, we didn't wait. Yeah, what did we do? We made a small app, Infinite Narrative, It's called. The goal is to play a text adventure with ChatGPT. What we did, we made a prompt for ChatGPT which said, "I like to play a text adventure with you, where you describe the world to me. For continuing the story, you ask me questions and I answer them." So you can play a story with ChatGPT. And the problem was a bit, it's annoying to write always an answer, because you have to write something. So we extended the prompt a bit and said, "Give me possible answers 1, 2, and 3, so I can only type 1, 2, and 3. So this was kind of cool, but we thought like a interface would be nice, like having an app. So we did an app which looked like this. It's called Infinite Narrative. ChatGPT suggests you a world where you can choose in which world you want to be. Then you choose a character, and then you have a story, and you can go through your adventure and play as long as you want, basically, or till you reach your goal. Somewhere in there is a goal where you want to reach, basically. If you want to download the app, it's on the Android store. On iOS, we still are struggling with some multi-platform stuff. Yeah. So, but also here, one small question. What do we do if ChatGPT decided to bias our players, like with political biases or anything else? We cannot handle it. We don't know if they try to tell you stories so that everyone is then left-wing or right-wing voters. We don't know the content. It's generated by ChatGPT, so we have to be careful here. For the conclusion, I give it to Patrick.
Yeah, so this leads us to the conclusion of our talk, and here also like a small moral obligation, I think. For most models, we actually don't really know what's really in there. I mean, sure, yeah, it's the internet or GitHub, but what's really in there? So regarding software, we don't know how it is licensed, and we could potentially infringe copyright, and also like users of our app or our library code could infringe copyright without us knowing it. So really be careful. The whole embedding process and the subsequent like mingling with neural networks is really complicated, and it's really hard to find out how or why it is actually working. There is ongoing research, and there are tools allowing you to do this, but currently it's really hard to attribute authors of the original work, especially like on GitHub. So also keep that in mind. And last but not least, the output probability distribution our neural network learns in the end, or the large language model learns, is based on the training set, which means it also has the same biases as the training set. So, for example, if we give all our job applications at Ubique to a neural network and ask it to like perform, to like evaluate new applications, we have this bias that probably, like, I don't know, 2 out of 10 applicants were male. So obviously our neural network learns, male people are better than women. And this is definitely a huge problem, and I think not really solved.
Yeah, maybe on the last part, so the biases or using the system outside of copyright, the EU has just published a first guideline about, or a legal framework where they classify every AI system into a risk category, and then depending on this risk category, the user of the AI tool needs to comply with certain duties to, for example, prohibit that such outcomes may arise. But yeah, the practice still has to show if it will actually solve, like if it effectively addresses the issues it tries to solve, or if it's more of a paper tiger. Good. I think with that we are...
And with that, we are finished.
Thank you.
All right, thank you very much. Are there any questions?
Yes.
just asking the obvious one, I guess. Like you showed all the kind of potential legal implications and potential problems with that. So shouldn't the conclusion then be that you just stop doing that stuff and stop putting apps out there that use it? I mean, just asking, right?
Yeah, I mean, it's difficult to say no there because it goes in this direction. The whole economy works with it, and I think the main reason here is to be careful and to think ahead what damage such a thing can do. I think this is our obligation, that we think what can happen if we use this technology and still be educated, and it's important that we know the stuff we are doing, so just don't copy-paste code and don't check what is happening in there. And that's why we also get decent education.
Regarding the putting apps out there, to be fair, infinite narrative has little potential of problematic content, I would say, because like the scenarios are predefined, and we have like we give the setting, which is like a fantasy setting or something, so it's...
There are 20 attributes in the app which are basically giving the settings. They are randomly chosen, so it's not every time the same.
And maybe a bit more of unsolicited legal advice. It's the same with any technology or for any company. At the end of it sounds corny that it's a business decision, right? But it's always risk to reward, and once you'll never get rid of any legal risk, right? So it's, as Cléa already said, it's mainly about being conscious and minimizing the risk. For example, DeepL uses AI, right? Using DeepL to translate, your documents as a regular office there's no risk there, right? Using it to screen applications, probably, you may be open to a lawsuit for discrimination or something.
All right, next question.
Yeah, I have a question, like how we supervise supervision bias or survivorship biasness, like who supervise this, that if we are having training data sets, but who design the training data sets may also have the some biasness. So how we minimize those biasness?
You mean like the example with the hiring? Or?
Yeah, like when we are training something, we are giving some data sets, and then how the sampling strategy has been done, that may also have it may also have supervised, the
input of the data. Yeah, but
sampling strategies may also have the biasness.
Yeah, sometimes we cannot. I mean, in the case of Copilot, what can we do with it? They just take everything on GitHub. If there is a shitty pattern there, which I don't like, how it's done in Android, I cannot remove it. Basically, I have no.
If we would try to train our own models with our own data, of course, it's really hard to know your biases, like either supervision bias or like implicit biases in the data set. So the only thing I could say is reevaluate the output of your neural network and check if it has biases, or be aware that it could potentially have biases. I mean, I think it would be fair to, it's a really hard question to answer.
And I think it comes back to the same as before. It's your responsibility, and at least at Ubique we live it this way. What you do is your responsibility, and you have to take care that you don't do damage to anyone. So I think this is
I'm asking this question because there was a critical application where I found this. So during World War II, there was a case. So there were bombers from UK, and they have to bomb in different adversary sites, and then when the bombers hit the site and then they get back to their own sites, then the military people give this question to the applied mathematics, like a panel of applied mathematics, and then they ask, now we need to put some armors on the bombers where they found the holes in the bombers, and then they ask the applied mathematics people that where we should put the armors. Armor is a kind of shield where you can make them more resilient to have not the holes. So the whole panel said this, that we should put the armor where we found the more holes. Like they have a fleet of bombers, and then they analyze where we have more holes, we should put the armors. But there was one mathematician, and then he said, you are doing a big mistake in this, because you are taking only those like cases where you found the holes. But he said, like, instead of putting the armor on the holes where you are finding the holes, you are putting a big mistakes, because you are not considering those aircraft which didn't return. Because then he said you had to put the armor on those places where there are not holes.
I think I understand.
So
the
that is
question.
kind of like survivor versus biasness, I mean to say.
But that's exactly, that's it. But that's exactly the point, right? All we can do is learn from history. So this mistake has already been made. So now in the AI world, it's the same thing. Try to be conscious of those biases and prevent them as good as possible. That's all we can do. Any more questions?
All right. Any more questions? Copilot. If not, or if you have further questions, of course, you can ask Ubique at their booth. They're just right outside. And also from VIScon. Unfortunately, I only have one arm to carry one. Thank you very much for coming, and thank you very much for your talk. All right. We have one more question. Sorry, I didn't see you.
Have you ever thought about training your own co-pilots in-house? Are you planning to do this if you want to?
Yeah.
We actually we were also for infinite narrative. We were trying to use Llama and Alpaca to use those, but the output wasn't really satisfying. But then we bought a used GPU. They were after the whole crypto crashes, the GPUs are affordable again. So we bought some for the office, where we have a super micro with 128 gigabyte RAM or so, to actually try out learning our own neural network. Because if you supervise your own data, you at least know what you input there. So
okay, thank you.
All right, last chance. If not, thank you again for coming. Thank you for your talk. And see you around.